There is no color out there. The electromagnetic radiation bouncing off every surface around you right now has wavelengths and frequencies and energies, but not color, not a trace of it. Color is something your brain generates after three types of cells in your retina absorb photons and fire electrical signals inward. And the proof, the clearest, strangest proof, is a single color you have seen thousands of times. Magenta. There is no wavelength of light on the electromagnetic spectrum that corresponds to magenta. It does not exist in any rainbow. It does not exist in the physics. Your brain invented it from nothing. And magenta, it turns out, is not the only one. But I will get to that. First, I need to show you what light actually is. Because what is entering your eyes right now is nothing like what you think it is. Now let me start with the basics. Because if you want to understand why color is not real, you first need to understand what is really entering your eyes. Light is electromagnetic radiation. That is all it is. It is the same phenomenon as the radio waves passing through your body right now, the same phenomenon as the microwaves heating your food, the same phenomenon as the X-rays that image your bones. The only difference in the physics is wavelength. Radio waves have wavelengths measured in meters, microwaves in centimeters, infrared in micrometers. And then there is this absurdly narrow band from roughly 380 nanometers to about 700 nanometers, where electromagnetic radiation happens to interact with certain molecules in your retina. That band, that sliver, is what we call visible light. It is less than 1% of the full electromagnetic spectrum. Let that settle for a moment. If the entire electromagnetic spectrum were a piano keyboard stretching from here to the far side of the sun, the visible portion, the part you can see, the part your entire experience of color is built from, would be a single key. You are peering at the universe through a keyhole and calling what you see through it reality. A photon at 550 nanometers does not carry a label that says green. It carries energy, E equals h times F, Planck's constant times frequency. That is its complete identity, a packet of energy oscillating at a particular frequency. There is nothing in the physics of that photon, nothing in the equations of quantum electrodynamics, nothing in its trajectory from the surface it bounced off to the back of your eye that corresponds to the experience of green. The greenness is not in the photon. It is not in the electromagnetic field. The greenness is added later. By you. Think about that. The greenness of every leaf you have ever seen, the blue of every sky, the red of every traffic light. None of those colors were in the light. Every one of them was added by the machinery behind your eyes. The light delivered energy. You supplied the color. Every physics textbook that prints the electromagnetic spectrum with a rainbow-colored band in the middle is doing something subtly misleading. The rainbow is not in the spectrum. The rainbow is in the textbook reader's brain. The spectrum itself is just wavelengths, numbers on a line, each corresponding to a different photon energy. We color-code it for convenience. But convenience is not truth. So if color is not in the light, where does it come from? The answer starts at the back of your eyeball, in a structure thinner than a sheet of paper, and it begins, quite literally, with a molecule changing shape. Your retina contains roughly 6 million cone cells. These are the cells responsible for color vision, and they come in three types, S, M, and L, short, medium, and long, named for the wavelengths they respond to most strongly. S cones peak at around 420 nanometers, deep in the violet range. M cones at around 530. L cones at around 560. 3 overlapping sensitivity curves. 3 channels. That is the entirety of your color universe. 3 channels of information feeding a brain that has to reconstruct the entire visible world from just those signals. And it turns out, not everyone has 3. There are people alive right now who have 4. They see colors you will never see. But that comes later. Inside each cone is a light-sensitive protein called opsin, bound to a small molecule called retinal, a derivative of vitamin A. When a photon strikes that retinal molecule, it physically changes shape. Chemists call this cis-trans isomerization. The molecule flips from a bent configuration, 11 cis-retinal, into a straightened one, all trans-retinal. All trans-retinal, one photon hits one molecule, and the molecule bends. That mechanical change triggers an electrochemical cascade that becomes a nerve signal traveling toward your brain. Color begins with a molecule bending. That is the physical event at the foundation of every color you have ever seen. One photon, one shape change, one impulse. Everything after that is interpretation. Close your eyes for a moment. Actually do it. Just for a second. What you are experiencing in that darkness is closer to the truth about light than anything you see with your eyes open. There is no color in the room around you. There is electromagnetic radiation at various wavelengths bouncing off surfaces. But color, the redness of a curtain, the brown of a table, that is not out there. With your eyes closed, the room is exactly as colorless as it appears to you. When you open them, your brain does not reveal the color that was there all along. It adds color that was never there to begin with. Let that sink in. Your brain does not receive color. It receives 3 numbers. How much did the S cones fire? How much did the M cones? How much did the L cones? From those 3 values, just 3, your visual cortex constructs the entire seamless, vivid world of color that fills your waking life. A world that feels as external and solid as the chair beneath you. But it is not external. It is a computation, a model, a very convincing guess your brain has been running without interruption since the day you were born. And the proof that it is a guess, the proof that what you see is construction rather than recording, comes from something called a metamer. This is where the story starts to get genuinely strange. A metamer is 2 physically different light sources that look identical to your eyes. Here is what I mean. Pure yellow light has a wavelength of about 570 nanometers. Shine it at your retina, and your M cones and L cones both fire strongly, while your S cones barely respond. Your brain says yellow. Now, if instead I shine a carefully calibrated mixture of 540 nanometer light and 580 nanometer light, the exact same cone ratios fire. Your brain receives the same 3 numbers. It says yellow again. Identical experience. Completely different physics. No human eyes can distinguish them because the 3-channel bottleneck reduces both signals to the same values. This is not a laboratory curiosity. This is not some edge case that only matters to vision scientists in specialized labs. This is how every screen you have ever looked at works. Your television does not emit yellow light. Your phone does not. Your laptop does not. They emit red, green, and blue. 3 wavelengths, and that is the entire palette. When you see yellow on a screen, what is actually arriving at your retina is a combination of red and green photons calibrated to trigger the same cone ratios as pure yellow light. The yellow is not in the light. The yellow is in your head. Think about that. You have watched thousands of hours of video, scrolled through millions of images, and not once, not a single time, were the colors you perceived actually present in the light entering your eyes. Every yellow, every cyan, every skin tone on every screen was a neural trick. 3 wavelengths manipulated to exploit the limits of your visual system. The screen provided the raw signals. Your brain did the painting, but metamers only prove that color is constructed from incomplete information. What comes next is deeper, evidence that your brain does not merely construct colors from physics. It invents colors that have no physics at all. Look at something magenta, a flower, a felt-tip pen, a shirt, anything in that color. Now consider this. Go to any diagram of the visible spectrum, the rainbow. Start at red on one end, around 700 nanometers. Move through orange, yellow, green, blue, and end at violet, around 380 nanometers. Magenta is not there. Not between any 2 colors. Not hiding somewhere you missed. It does not exist on the electromagnetic spectrum. What magenta actually is, and I find this remarkable, is what your brain generates when your L cones and your S cones fire simultaneously without significant M cone activation. The red sensitive cones and the blue sensitive cones respond together. But in the physical spectrum, red and violet sit at opposite ends. There is no wavelength of light that is simultaneously shorter than violet and longer than red. That is a physical impossibility. So your brain does something extraordinary. It closes the spectrum into a circle, the color wheel you learned in school, by fabricating a hue to bridge the gap. A hue that exists in no rainbow, on no spectrum, in no equation of electrodynamics anywhere. Magenta is an invention, a beautiful, consistent, repeatable invention that every trichromatic human brain generates under the same conditions. But it has no counterpart in the external world. Think about that for a moment. You have been seeing a color your entire life that has no corresponding reality in the electromagnetic field. It is not that we have not found the right wavelength yet. There is no wavelength to find. Magenta is something your brain creates from nothing, and it does it every single time the same way in every human brain with 3 working cone types. A shared hallucination, species-wide. And magenta is not alone. Pink is non-spectral. No single wavelength of light is pink. White is non-spectral. Your brain produces it when all 3 cone types fire roughly equally, regardless of which wavelengths caused it. And brown. Now, brown is fascinating. Brown is what happens when your brain perceives the wavelengths of orange in a context where brighter light surrounds it. The same frequencies that produce vivid orange against a dark background produce the experience of brown when the surrounding scene is brighter. Your brain takes the context, evaluates relative brightness, and generates a completely new color that has no corresponding wavelength. Brown is dark orange, but you would never know that from looking, because your brain handles the subtraction silently, without asking and without telling. If you find that hard to believe, try this. Open any image editing program. Pick a pixel you perceive as brown and check its hue value. It will be orange every time. The difference between brown and orange is not in the light. It is in the context your brain wraps around the light. Change the surroundings and the same pixel shifts from one color to the other before your eyes. The photons did not change. Your interpretation of those photons did. You see, your brain is not a camera. It is an interpreter, making comparisons across the entire visual field and generating a color model that is useful for the organism. And it does this so automatically, so silently, that you have spent your entire life believing color is something you discover in the world rather than something you impose on it. Now, up to this point, I have been telling you what color is. But there is a second story here, a human story, about how long it took us to figure this out. And it begins with a man, a glass prism, and the deadliest pandemic in English memory. In 1666, Isaac Newton was 23 years old and in hiding. The Great Plague was tearing through England. Cambridge had closed its doors. London was burying the dead in mass graves. And Newton, with nowhere to go and nothing but time, retreated to his family's estate in Woolsthorpe. He darkened a room, cut a hole in the shutters, and let a narrow beam of sunlight pass through a glass prism. The light fanned into a band of colors on the far wall. People had played with prisms for centuries. That was not new. What Newton did next was the breakthrough. He passed that spread light through a second prism and recombined it back into white. This proved white light was composite, not pure. The colors were already in the sunlight, merely separated by refraction. But here is the part nobody talks about. After proving the spectrum was continuous, a smooth, unbroken gradient with no natural divisions anywhere, Newton divided it into 7 discrete colors: red, orange, yellow, green, blue, indigo, violet. Why 7? Not because there are 7 boundaries in the physics. There are none. Newton chose 7 because he wanted an analogy with the 7 notes of the musical scale. He believed in a deep harmony between light and sound. It was an aesthetic preference, an intellectual ambition, and it was entirely arbitrary. 350 years later, every schoolchild learns ROYGBIV, a cultural artifact invented by a plague refugee chasing a metaphor, taught as a fact of nature. The rainbow does not have 7 colors. The rainbow does not have any number of colors. It is a continuum. The boundaries are ours, not nature's. Now Newton could split light and recombine it. But he could not answer the deeper question: why do humans see color at all? What is happening inside the eye? That question waited more than a century, until a young English polymath named Thomas Young proposed an answer so strange that most of his contemporaries dismissed it. In 1802, Young stood before the Royal Society and argued that the human eye does not contain a separate receptor for every color. That would require thousands of different cell types, an anatomical impossibility. Instead, Young proposed that just 3 types of receptor, each sensitive to a different range of wavelengths, could account for the full range of human color experience. 3, not hundreds, not thousands. 3 overlapping responses, and the brain does the rest. The idea was elegant, radical, and largely ignored. It took another 60 years for Hermann von Helmholtz to formalize it mathematically, and another century beyond that for physiologists to actually find the 3 cone types in the human retina and confirm Young was right. But here is the part I find beautiful about Young's insight. He understood 200 years ago that color was not a property of light. It was a property of the observer. The light provides the stimulus. The brain provides the experience. And if the brain only has 3 channels to work with, then everything you see, every shade, every subtle distinction, is the brain's best guess from limited data. Young understood this in 1802. We are still coming to terms with it. We say the sky is blue as though blue were a property of the sky, like its altitude. But blue is what happens inside your visual cortex when scattered 470 nanometer photons arrive at your retina. The sky has no opinion about its color. The sky does not have a color. You do, one your brain assigns to the sky. That distinction sounds philosophical. It is not. It is physics. Now Young and Helmholtz established that color is constructed from 3 channels. But it took yet another century for someone to prove just how aggressively the brain constructs color from context rather than reading wavelengths like an instrument. That someone was Edwin Land, the founder of Polaroid, very brilliant fellow. In the 1970s, Land conducted demonstrations that shook vision science. His experiment was deceptively simple. He took 2 black and white photographs of the same scene, one through a long wavelength filter, one through a short wavelength filter. Then he projected them simultaneously, the long wavelength image through a red filter and the short wavelength image through no filter at all, just white light. By the physics, the only wavelengths hitting the screen were red and white, no green, no blue, nothing in the short wavelength range that could stimulate S-cones appropriately. And yet observers saw a full range of colors, greens, blues, yellows, appearing vividly in a scene illuminated by only red and white light. The absolute wavelengths reaching the eye were wrong for nearly every color people reported seeing. But the relative comparisons across the scene. This surface reflects proportionally more of this wavelength than that surface, were enough for the brain to assign colors anyway. Land called this Retinex theory, a combination of retina and cortex, and the implication cut deep. Your brain does not measure wavelengths and look them up on a chart. It computes ratios. It compares every surface in the visual field to every other, evaluates relative balance, and paints colors based on relationships rather than raw physics. This is why a white sheet of paper looks white in candlelight, fluorescent light, and sunlight, even though the wavelengths reaching your eyes are completely different each time. Your brain normalizes. It maintains the illusion of color constancy because stability is more useful to a navigating organism than accuracy. Your brain cares about being useful. It does not care about being honest. I find this genuinely beautiful. Not beautiful because it is comforting. It is not particularly. Beautiful because it reveals what the brain actually is, not a passive recorder of reality. An active artist. A system that takes fragmentary, ambiguous data and builds from it a coherent, stable, useful world. And it does this so seamlessly that you never notice. You walk through your life trusting the colors you see as though they are facts about the external world. They are not facts about the external world. They are facts about you. And this opens up the strangest chapter of all. Because if color is a construction assembled by particular biological hardware, then different hardware should produce different colors. Different organisms looking at the same photons should experience different worlds, and they do. Dogs have two types of cone cells, dichromats. Their visual world is not lesser, it is different. 2 channels instead of 3. The same photons enter a dog's eyes and yours. The models. The 2 brains built are not the same. And neither model is more correct, because neither corresponds to anything that exists in the electromagnetic field. A dog watching a sunset with you is not seeing a washed-out version of what you see. It is watching a completely different sunset, constructed by a completely different visual system from the same photons. Both sunsets are real to the brains experiencing them. Neither sunset is real to the physics. Neither one is the correct sunset. The mantis shrimp has 16 types of photoreceptors. When this was discovered, science writers celebrated what they assumed was the richest color vision in nature, an animal perceiving hues beyond human imagination. But in 2014, Hannah Tuan and her colleagues at the University of Queensland published a study in Science that overturned that romantic assumption entirely. They designed careful behavioral tests showing mantis shrimp pairs of colors and measuring whether the animals could tell them apart. And they found these 16-channel creatures were actually worse than humans at distinguishing similar hues. 16 channels did not mean finer perception. It meant a different kind, faster recognition perhaps, useful for identifying friend from foe in a split second at the cost of subtle discrimination. The mantis shrimp is not seeing a richer version of your world. It is building an entirely different world from the same photons. But the most extraordinary part of this story concerns not shrimp or dogs. It concerns other humans alive right now, walking through the same cities as you, watching the same sunsets. Remember what I told you earlier about people who have 4 channels instead of 3. Here is that story. In 2010, Gabriella Jordan and her team at Newcastle University confirmed the existence of human tetrachromats, people, almost always women, who carry a functional 4th type of cone cell due to a mutation on the X chromosome. Jordan had been searching for verified tetrachromats for over 20 years. The genetics predicted they should exist. Roughly 2 to 3% of women carry the gene for a 4th cone type. But carrying the gene and actually using the 4th channel are different things. The brain has to wire itself to incorporate that extra signal. Most women with the mutation appear to remain functionally trichromatic. Jordan's team designed color matching tests so sensitive that only a true tetrachromat could pass them. Tests where the distinction between 2 color patches was invisible to any trichromatic observer, no matter how keen their eyesight. And after 2 decades of searching, they found one. A woman, identified in the literature only as CDA29, who could consistently distinguish color differences that were mathematically invisible to 3-cone vision. The 4th cone sits between the standard M and L cones on the sensitivity spectrum, creating a new channel the brain genuinely incorporates into its color model. And the implications of that are genuinely unsettling. A tetrachromat, looking at the same leaf you are looking at, may perceive gradations within what you see as a single shade of green. She is not seeing more of what is physically there. What is there is photons carrying energy, identical for both of you. She is building a higher dimensional model from a wider input. 4 channels instead of 3. And from those 4 channels, her visual cortex constructs a color space with potentially millions more distinguishable points than yours. She cannot describe those extra colors to you. You do not have the hardware to perceive them. She cannot point to them on any chart, because every chart ever printed was designed by trichromats for trichromats. She inhabits a visual world that overlaps with yours, but extends into territory permanently sealed to you, not because the light differs. The light is identical, but because her brain builds a different world from that light. Think about what this means. 2 people stand together watching the same sunset. The same electromagnetic radiation enters both pairs of eyes. Those photons carry no color. They carry energy, E equals H times F, and nothing more. Inside one skull, a trichromatic brain constructs a sunset from 3 channels. Inside the other, a tetrachromatic brain constructs something subtly, irreducibly different from 4. Both experiences are consistent. Both are useful. Neither corresponds to anything that exists in the electromagnetic field between the sun and the horizon. The sunset is not orange. The photons have no beauty in them. The beauty, all of it, is something a brain does. Your brain, working in total darkness behind your eyes with nothing but 3 types of molecular switches and roughly 100 billion neurons trying to make sense of the signals. And from that darkness, from that complete absence of color in the physical world, it builds everything you see right now, every hue in the room around you. The blue of the sky if you are near a window, the color of your own hands. Look at your hand. Whatever color you see, the pinkness of your palm, the particular shade of your skin, is not there. The photons bouncing off your hand carry wavelengths, not colors. Your retina catches some of those photons, 3 types of molecules bend, 3 channels of numbers travel inward, and somewhere in the darkness behind your forehead, your brain paints your hand the color you see. It has been doing this every moment of your life. It will never stop, and until a few minutes ago, you probably never questioned it. There is a way to hear this and feel diminished, to feel that the vivid world you trust is a fabrication. But I think that misses the deeper truth entirely, because what is actually happening is far more extraordinary than passive reception could ever be. Every sunset you have watched was a collaboration between the universe and you, specifically you. The electromagnetic radiation provided raw material, waves at 400 trillion cycles per second, scattered and absorbed and re-emitted by every atom in the atmosphere. And then this particular arrangement of molecules that has never existed before and will never exist again, took those waves and did something no spectrometer can do, something no equation describes. You made orange. You made beauty. You turned meaningless oscillations in an electromagnetic field into the experience of a day ending gorgeously. The physics delivered the photons. You made the color. You have been painting the world since the moment you first opened your eyes, and you never noticed, because you have never once seen it unpainted. That is not sentiment. That is what the science says.